Hi, I'm Alec. Today we're going to go over scientific notation.
Scientific notation is a way of writing very large or very small numbers using powers of 10. It takes the form of a times 10 to the n, where a is known as a mantissa. It's between the numbers of 1 and 10. N is the exponent, and n can be any integer. Some examples of scientific notation are 1.5 times 10 to the 8th. 1.5 is a mantissa, and 8 is the exponent. 2.3 times 10 to the 2. 6.001 times 10 to the 5th. Like we discussed earlier, the exponent can also be negative. 3.65 times 10 to the negative 2. 3.65 is a mantissa, and negative 2 is the exponent. 4.321 times 10 to the negative 1, and 7.0 times 10 to the negative 6.
We're going to start by converting from standard to scientific notation. Our first example would be the distance between the Earth and the Sun, which is 150 million kilometers. We begin by assuming that the decimal point is at the end of the number, and then we're going to move it between the first two non-zero numbers, which are between the 1 and the 5. After moving the decimal place, we're going to count how many places from the original point to its new point. Therefore, our mantissa becomes 1.5, decimals in between the two first non-zero numbers, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8 places. 8 becomes your exponent. 1.5 times 10 to the 8th kilometers. Our exponent 8 is positive because we started with a large number and we're moving a decimal point from right to left. In our previous example, we turned a large number in standard notation to scientific notation. In this example, we're going to turn a small number, the diameter of a flu virus, into scientific notation. We're going to start by locating our mantissa. Our first two non-zero numbers are 1 and 6. Therefore, our new mantissa will be 1.65. From there, we're going to count how many places you move the decimal point to get your exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your exponent will now be 10. 1.65 times 10 to the negative 10. Your exponent is negative 10 because you took a small number into scientific notation, moving the decimal place from left to right. The next thing we'll cover is converting from scientific notation to standard notation. When working with numbers in scientific notation, you can tell if you're working with a small or large number based on the exponent. Remember that positive exponents denote large numbers and negative exponents denote small numbers. For this example, we're going to convert the average distance between Earth and Mars from scientific to standard notation. 2.25 times 10 to the 8th kilometers. 8 denotes that it's a large number. So, to start, we're going to write 2.25. From there, we're going to move the decimal place 8 times from left to right. 1, 2, 3, 4, 5, 6, 7, 8, and put your new decimal place. You fill in all these spaces with zeros and your units of measurement. So your answer in standard notation is 225 million kilometers. In this example, we're going to convert the average size of a red blood cell from scientific to standard notation. Note that your exponent is negative, meaning that this number is going to be very small. We're going to start by writing 7.0. Now we're going to move the decimal place from right to left, 6 places. 1, 2, 3, 4, 5, 6, your new decimal place. Fill in the rest with zeros, and your new answer will be 0.000007 meters. Next, we'll talk about basic math operations with numbers in scientific notation. Multiplication in scientific notation. It can be written symbolically as a times 10 to the m times b times 10 to the n. The mantissas can simply be multiplied together, a times b times 10 to the m plus n. The exponents are added to each other. For an example, we have 2.2 times 10 to the 6th times 1.1 times 10 to the 4th. The mantissas 2.2 and 1.1 are multiplied together to get 2.42 times 10. Exponents are added to each other to the power of 10. If you're multiplying two numbers in scientific notation that have powers of 10 that are of different signs, you would simply add the exponents. For example, 3.2 times 10 to the negative 3rd times 2.1 times 10 to the 5th. The mantissas 3.2 times 2.1 equals 6.72. And for the exponent, negative 3 plus 5 is positive 2. 6.72 times 10 to the 2. Next is division in scientific notation. Symbolically, they can be written as a times 10 to the m divided by b times 10 to the n. The mantisses are simply divided, a divided by b, and your powers of 10 are subtracted, m minus n. For a numerical example, we have 4.5 times 10 to the 6 divided by 2 times 10 to the 2. The mantisses 4.5 and 2 are divided by each other, and the powers of 10 are subtracted, 6 minus 2. Your final answer will be 2.25 times 10 to the 4th. So now that we've covered scientific notation, working with numbers like this can be made much more simpler. Also remember that even though we did not cover significant figures, they are still used in scientific notation. Thanks for watching these videos.
I didn't screw up and you're still
Go.
I didn't even start yet. And your powers of 10 subtracted, 6 divided